All right, inverse functions. Let's start with f of x equals x plus 2. And let's do g of x equals x minus 2. Just to let's make a short little table here. If x is 2, what's f of x?
4.
Okay, 4, 3, 4, 5. All right. Now, let me make x and g of x here. Let me start at 4 here. If x is 4, g of x is? Okay. Now, what do you notice? Okay. The x and y tables are just turned around here, right? Okay. F of x and g of x. And if that's true for all values, f of x and g of x are inverses. Inverse functions. Okay? Now, some characteristics of, there's two we're going to talk about, of inverse functions. Graphically, f of x and g of x are symmetric over the line y equals x. Okay. Now, I'm going to quit using g of x. If they are inverses, I'm going to change the notation. This is the inverse of f of x. Okay? And second, algebraically, f, the composite function, f of the inverse function of f of x is equal to x. And also, the inverse function of f of x, inverse function of the function of x, I should say, is also equal to x, if you do that composite function. Okay. So far, so good? All right, do you guys have your calculators handy? Do I have mine handy? Yep. Okay. Let's start. Oh, the other thing I should mention, you know, we talked about graphically, it'll be symmetric over y equals x. Algebraically, you use composite functions. If you get x in both arrangements, they are inverses. Numerically, if the tables are switched around, then that shows that they are inverse functions. Okay? I didn't talk about numerically there. Now, let's start with f of x equals two x cubed minus 1. G of x equals the cube root of x plus 1 over 2. Okay, let's use our calculator. Okay. So let's put y equals 2x cubed. So go to the third power. I'm going to hit the right arrow so that I'm out of the exponent. Minus 1. 2x cubed minus 1. I'm just going to hit graph. Okay, something like that. Okay. Look at your function. Check real quick. Okay. Hit the zoom and then 6. You're just seeing a small part of it, and it kind of looks like a straight line. Okay? All right. Now, to put this one in. Okay, to get the cube root, there's two ways of doing it. One way is to, it actually is programmed on the calculator. Cube root is. So you can do that. Or you can, if you want a fourth root or a fifth root or something, you could use the number 5. But we just need the cube root, so I'm going to use number 4 there. And then I've got to do x plus 1 over 2. I am going to put x plus 1 in parentheses and then divide by 2. And then I'm going to hit graph there. And you can see that one going. Is everybody good there? Now, we were saying that these are what? What is the characteristic, the graphing characteristic of inverse functions? Symmetric over what? Y equals x. Well, let's do a third equation. Y equals x. Now, I wanted to see if you know this. If you go over here all the way to the far left, you can change the kind of line it graphs. Like here, it'll graph a regular line. I'm just hitting enter each time. Is it blinking there? You see that? Or you can make a bold line, a bolder line. You could shade the top part, or you could shade the bottom part if you wanted. It'll kind of show the path it goes and leave the line behind, or it'll just follow the path without leaving a line behind, or it'll do a dotted line, and that's what I'm going to do here. Graph the dotted line. Okay, now when you look at this, and I'm going to show you something else we can switch around. You see how this cuts right through there? This is the first function. This is the second function. And it goes right through here. This point right here is where the two meet. And if I go here to the line to here, do you see the symmetry there between the two over that axis and the symmetry over that axis? You might, with the newer ones, be able to change colors that you, or might do it for you. There is a zoom function. Do you notice that the y points are placed a lot closer to each other than the x points? You can square that up if you want. If you hit zoom and number 5, you can make them both the same amount of distance. And that shows me the y equals x just cutting straight through that axis, or through the quadrants, I mean. All right, do you see the symmetry over y equals x, how that works there, what that looks like? Okay. All right, that's one thing I wanted you to see. That's graphically. Algebraically, I want to know what f of g of x is equal to. It's supposed to be x. Let's make sure. And sometimes we have to, if we have to prove it, we have to go through the algebra to do that. All right, so f of g of x, that is f of the cube root of x plus 1 over 2. Okay, the f function says take 2 times your input, which is the cube root of x plus 1 over 2, raise that to the 3rd power, and then subtract 1. All right. What's the first simplifying we should do there, Quinn? The cube root and the cube are canceling out. So let's go 2 times x plus 1 over 2 minus 1. Quinn? The 2's do cancel out. Okay. So we do get x like Jack said we should. It may be, I don't know what the functions look like, but it might be possible that g of f of x is not x, in which case you don't have inverse functions. But, so that's why we're going to show this. G of 2x cubed minus 1, which is the g function. We take the cube root, our input is x, right there. So for x, we're replacing it with 2x cubed minus 1. Then we have this plus 1, and then that's over 2. Here's our input plus 1 over 2, right? Cube root minus 1 plus 1 cancels out of 2x cubed over 2. What would you do next? Christian? Cancel out the 2's. Yep, that's an accident. Cube root of x cubed is x. All right, so g of f of x is equal to x, and f of g of x is equal to x. That means f of x and g of x are inverses. Okay? Any questions there? All right, the next thing we're going to do is find inverses. Step 1. Okay. Replace, if you're in function notation, replace f of x with y. Step 2. When you've done that, switch x and y around. Step 3, solve for y. Get y by itself. And step 4, after now take y back out and replace that y with the inverse function notation, inverse function of x. Okay? It's a 4-step process. Let's do it for a couple. Everybody got that down? All right, so let's find the inverse of f of x equals x to the third minus 4. Okay, step 1. John? Okay. Stephen? Change the f of x to y. All right. I'll just write a little note what we're doing. Okay, Ryan?
Switch y to x.
So x is where y is, and y is where x is. Now what? Christian? Let's solve this for y. All right. So I probably need to add 4 first. I got x plus 4 equals y to the third power. Quinn? Take the cube root of both sides. That's an inverse function of the third power. Good. So I got the cube root of x plus 4 is equal to, this is why you did that, it's equal to y. We've solved it for y. And the cleanup step, the finishing step here. Ryan?
Instead of y, do you want to put x, -1x?
Okay. F of x is x to the third plus 4. The inverse of f of x is the cube root of x plus 4. Any questions? All right, let's do it for one more, and I'll be done up here. So let's find the inverse of f of x equals the square root of 2x minus 3. First, Cohen? Nope. Zoe? Wrong class. All right, yes. Let's see. You either just totally blown me off or I said the wrong name. And I said the wrong name. Okay. Now, next. Go ahead, Zoe. You're on a roll.
Switch to x and y.
Okay. Now what?
Then you solve for y to square it.
All right, let's do that.
Yeah, I agree.
Yeah, let's do that first. The reverse of order of operations, because we're solving. Okay?
And then you divide it.
Right. And the finishing touch.
Switch out y for the inverse function of x.
Okay. All right. Any questions there?